Hai, selamat sejahtera. I am Puan Hanisa. Okay, in my previous video, I discussed about the gradient. Okay, the gradient of distant time graph. Okay, and for this video, my second video, I'm going to discuss still in chapter 6, gradient and area under a graph, but I want to discuss the gradient and area under the graph for speed time graph. Okay, we revise a little from the previous video. Distant time graph. Okay, distant time graph. In distant time graph, you learn that the gradient of the gradient of the graph is equals to the speed, or uh, other sentence, rate of change. Okay, in other sentence, rate of change of distance with respect to time. Okay, so speed is the rate of change of distance with respect to time. Okay, so the speed is equal to the gradient. If you want to find the speed, you must find the gradient. If the question asks you to find the rate of change of distance with respect to time, you must find the gradient. Okay, this is for distant time graph. Okay, our focus today is about speed time graph. Okay, for speed time graph, there are two things that you must know. One is about the gradient, and two is about the area under the graph. Okay, this is speed time graph. I'm sure you know why this is speed time graph, because the horizontal axis is time and the vertical axis is speed. Okay, speed to time, speed time graph. Okay, there are some example of the graph. Okay, this is speed time graph, and you see that it is a horizontal line. Okay, horizontal line in speed time graph means that the speeds are uniform. This is uniform speed. Why this is uniform speed? Because you can see here the value of speed is always 30, so that's why it is uniform speed. Okay, the second one, okay, the speed increase, that means the movement become faster. Okay, zero here. Okay, zero here means that it's not moving, and then when it's moved, it become faster. From 0 meter per second, it move until it reach 24 meter per second. Okay, this one start with 10 meter per second. Let's say, okay, let's say 10 meter per second. Okay, the speed become less. Okay, it becomes slower until it become 6 meter per second. Okay, that's mean the movement become slower. Okay, this graph represent, okay, this graph represent the movement is already 20, and it increase again until it reach 40 meter per second. And the last graph here show that this is the combination of all types of line. Okay, you see that here is increasing in speed, this is uniform speed, and this is decreasing in speed. Okay, these are some example of speed time graph. Okay, now we look at the gradient. What is the gradient of the speed time graph represent? Okay, the same word here, rate of change, is the rate of change. Okay, the rate of change of speed with respect to time. Okay, because, okay, you remember the changes of the vertical with respect to the horizontal axis. So the rate of change of speed with respect to time. Okay, S over T. Okay, the changes in speed, okay, changes in speed over over time is equals to acceleration. Okay, I'm sure you already learned about acceleration in form 3. Okay, so acceleration is the changes in speed over time. Okay, the time taken for the speed to change. Okay, so if you have this type of graph, okay, the speed here increase. Okay, when you calculate the gradient is positive, this is acceleration. Okay, when you calculate this gradient, okay, the gradient for this graph, the value of gradient you will get is negative. Negative signs represent the deceleration. Okay, it becomes slower, so it is deceleration. Okay, for this graph, it accelerate from 0 to 40, and then it maintain the speed. After that, it decelerate until it's stop. Okay, so let's do some example. Okay, how to calculate the acceleration? Okay, the question is find the rate of change of speed, okay, according to with respect to time. Okay, with respect to time. So when the question said find the rate of change, okay, in your mind, okay, what you must think? You must think of the gradient, okay, because this is speed time graph, so think of gradient. Or maybe the question will strictly or directly use the words acceleration. Find the acceleration. Okay, so this one also you must find the gradient. Okay, so the question might use the word rate of change. Okay, some question might use acceleration. Okay, so to calculate the acceleration, you must calculate the gradient. For speed time graph, the gradient is equal to the acceleration. Okay, so this point is 0, 0. This point is 40, 24. Okay, so how to calculate the acceleration? Use the formula of gradient. Okay, in case you forgot, so I write again, m equals y2 minus y1 over x2 minus x1. Okay, so acceleration equals to 24 minus 0 over 40 minus 0, so equals to 24 over 40 equals to 0.6 meter per second square. Okay, because this is meter per second, this is second, so meter per second square. Okay, next question. For this graph, calculate the acceleration. So how to calculate the acceleration? Okay, the same thing. Find the point 20 and 40. This is 0, 20. So acceleration is 40 minus 20 over 20 minus 0. So equals to 20 over 20. So equals to 1 meter per second square. Okay, simple, right? Find the gradient only. Okay, for this diagram, okay, this is 0, 10, and this is 8, 6. So 10 minus 6 over 0 minus 8, so equals to 4 over negative 8, so equals to negative 0.5. Okay, this negative indicates that the movement becomes slower. Okay, this is acceleration. Acceleration equal to negative means the movement becomes slower. okay, the speed is lower, that means it is deceleration. Okay, deceleration equals to 0.5. You don't have to put negative here because you already write deceleration. But if you write acceleration, you must put the negative. Okay, because the negative indicates that the movement is slower. Okay, while deceleration here already tell you that it is slower. 0.5 per second. Okay, that's mean every 1 second it decrease in speed 0.5. Okay, 1 second less 0.5, another 1 second less 0.5. Okay, that's the meaning of deceleration. Okay, next question. Okay, for this question, the question might ask you find the rate of change for the first 10 second. Okay, or maybe the question will ask you to calculate the acceleration for the last. Okay, last for this diagram is okay 15 second. Okay, so based on this keyword, okay, you must answer the question. Okay, for A it said first 10 seconds, so you must look from here to here because 10 seconds is from here to here only, so dot 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 dot. Okay, this is the point. The coordinate here is 10, 40, while here is 0, 0. Okay, so for A, the acceleration equals to 40 minus 0 over 10 minus 0, so you get 40 over 10, so answer is 4. Okay, 4 meter per second square. Okay, question B. The same method, but because it said last 15 seconds, so you must look at the last 15 seconds. So from here to here, 35 minus 20 is equals to 15, so that's why it is last 15 seconds. Okay, so this point is 20, 40. This point is 35, 0. So acceleration equals 40 minus 0 over 20 minus 35. Okay, you already see that the graph is going down, right? It decreased in speed, right? So make sure, okay, your answer must have negative. Okay, in case lah, if you calculate the answer and then suddenly you find positive, and then when you look at graph, it's impossible to have positive answer. So you must know that maybe your solution is wrong somewhere, so you must recheck your answer. Okay, let's check. Okay, this one, negative 40 over 15. Okay, so equals to negative 2.67 meter per second square, or you can write as fraction also, it's negative 8 over 3 meter per second square. Okay, so that's how you calculate the acceleration for the speed time graph. Okay, but for this last question, you must be careful because the question might ask you this, okay, this A, or might ask you B. Okay, what if the question asks you to find the acceleration for first 5 seconds, or the question asks you to find the acceleration for last 10 seconds? So how? Okay, same method. Fine, 5 is somewhere here, right? Okay, so okay, this, let's say this is the point. Oh, you don't know what is the value here. So don't worry. Okay, because you can see that the the increase in speed here are same, right? Okay, so the gradient from here to here should be same from here to here, because you can use any value on this graph to find the gradient. Not necessarily you use this point and this point only. If you know this point, you can find the gradient, and the gradient will also same as this one. So if the question asks you to find the acceleration for the first 5 seconds, you use this method. The answer would be this. Last 10 seconds also same. Okay, 10, let's say somewhere here is 10. You don't know what is the point here, so you use this point and this point. So the answer for this one is this. Okay, so don't worry, it's not very hard, and it's not hard, I think it's easy but not very easy. Okay, next. Now we are going to discuss about the area under the graph. Okay, for speed time graph, the area represent the distance traveled within the given time. Okay, that's mean when the question asks you to find the distance for the journey, you must find the area under the graph. Okay, so for this topic, okay, for this subtopic, you must remember, okay, you recall that how to find the area of these shapes. Okay, we have triangle here. Triangle, how to calculate area of triangle? Area of triangles equals to 1/2 times base, the length of base, times the height. Okay, this is how you calculate the area of triangle. Okay, is it same for this one? Yes, also can. You can use this formula, or if you know this length on this length, you also can divide into two triangle. Okay, also can. Okay, next, for this one, what is the shape? What is this? This is trapezium. Okay, trapezium is like this, or maybe it's like this straight line, and you have two parallel line, and another line like this. This is also trapezium. This is also trapezium. Okay, okay, some trapezium is drawn like this. Okay, or it will be drawn like this. Okay, so no matter where is the direction, this is still a trapezium. So how to calculate area of trapezium? Area of trapeziums. Okay, area of trapezium. Okay, this is A, this is B. Label the parallel line of the trapezium as A and B. If you want this B, this A also can, no problem, as long as one is A, two is B. Okay, and this straight line, okay, is height. Okay, so 1/2 times A plus B times height. Or you can write as H/2 A plus B also can. Okay, this is how you calculate area of trapezium. Okay, so for this one, area of triangle. Okay, can you calculate area of triangle? 1/2 times 5 times 3. Okay, because for triangle, okay, this is the base, and the height is this one, not this inclined line. The height is this one. Okay, so for this diagram, triangle also same. This is the base, and the height is this one. Okay, for this one no problem because you have this straight vertical line. So this is the H. Okay, so I hope you remember. Okay, please revise how to calculate the area of triangle, area of trapezium. Okay, because you need to use this formula to find the distance travel. Okay, for the speed time graph. Okay, so you see for this one, okay, the graph is like this. So to find the distance, okay, you must draw a dotted line here, and then you calculate the area under the graph. Okay, remember area under the graph. This is the region under the graph, not this one, not this one. Okay, area under the graph. Okay, okay, this one is this area under the graph? No, this is above the graph. So below the graph is this one. Until 40, so you stop here only. Okay, this is the border. Okay, this one is, oh, rectangle. I forgot to revise the area of rectangle just now. Area of rectangle or cube or, oh, sorry, cube. A square or a rectangle, you must have the length and width. Okay, area equals to length and width. Length times width. Okay. Okay, next. This one, the combination. The combination of all. So you can see here the area is, okay, you can straight away use the shape trapezium. This is trapezium, right? Or if you don't remember how to use the formula of trapezium, you can separate it into three shapes. Okay, this is this is triangle. The first one is here, A is triangle, and B here is the rectangle, and this is also the triangle. Okay, so no problem, right? Okay, this one, okay, is also a trapezium. See, trapezium, oh no, cantik. Okay, this is trapezium, but if you don't remember formula trapezium, you can use area of triangle plus area of square. Square ke ni? Bukan. This is rectangle. Okay. Remember? Area under the graph. That's why I only focus on this side, not this side, this side. Okay? Under the graph. Okay, next. Okay, let's count. Let's calculate. For this graph, okay, this is triangle. Okay, this is triangle. So the length here is 40. How I know 40? Because this is 0, this is 40. 40 minus 0 is 40. Okay, this is 0, this is 24. So the height here is 24. Okay, so to find the distance for this journey, okay, so 1 over 2 times 40 times 24. So equals to, calculate. 1 over 2 times 40 times 24. The answer is, okay, 480. Okay, I assume you count it correctly. Okay, this is easy, right? Meter. Why this is meter? Because this is meter per second. This is second, so meter. Okay, easy, right? Next. Okay, for this graph, the shape is trapezium. This is the shape of trapezium. Okay, the shape of trapezium. The height of the trapezium is this one, 20. And you remember the two parallel line? Okay, this is parallel to this, so this is 20, this is 40. So formula is 1 over 2 times A plus B times height, right? Okay, so this is the A, this is the B, this is the height. So you substitute inside 1 over 2 times 40 plus 20 times with 20. So equals to 600 meter. Okay, if you don't remember the formula of trapezium, I really hope that you can remember. Okay, but if you cannot remember, no problem. You separate this into two parts. Okay, this one is the square. You see, this is 20, this is 20. So this is square. Area of square is 20 times 20. Okay, and then you must plus with the area of triangle. This triangle. Okay, this triangle. 1 plus, okay, 1 over 2 times, okay, the base is 20 times, the height is from here, not from this, from here. Okay, this is 40, this is 20, so 40 minus 20, so this is 20. Okay, you will get the same answer. Okay, no problem. Okay, next. Okay, this one. Okay, the same diagram as just now. Actually, you can straight away use the trapezium. 1 over 2 times, okay, this is A, this is B, this is total, from here to here is 10, from here to here is 6, and the height here to here is 8. So 1 over 2 times 10 plus 6 times 8, so equals to 64. Okay, so the answer is 64 meter. Next, okay, this one, the combination. Okay, you can straight away use the area trapezium, use the whole shape like this. Okay, this shape is trapezium. The total here is 35. Okay, here is from 10 to 20, right? So this is 10. Okay, and the height, okay, the height you must take this vertical line, okay, or this one. Okay, don't take the inclined line here. Okay, from here to here is 40, so the height of the trapezium is 40. So 1 over 2 times 35 plus 10 times with the height is 40, so the answer will be 900. Okay, if you don't want to use trapezium, no problem. You can separate into triangle, rectangle, triangle. So you must have these three values to add. Okay, the first one is the first triangle. So this is 10, height is 40. 1 over 2 times 10 times 40. Okay, plus, okay, this one is area of rectangle. 40, this is 10. 10, 10. Okay, so 10 times 40 plus the last triangle, 20 to 35 is 15. The height is 40. So 1 over 2 times 15 times 40. Your answer would be 900 meter. Okay, next. Find the area of the graph. Okay, so you see the movement. They say this is speed, this is time. You see the movement. This is 0, not moving. Increase and then maintain, and then increase speed, and then decrease, and then increase again. So for these speeds, how long that how long is travel? Okay, so you must add all the area under the graph you want to find, if you want to find the whole for the whole journey. Okay, so you can divide it into rectangle, sorry, this is triangle, and then this is rectangle, this is trapezium, this is trapezium, this is trapezium, or uh, this one, this one is trapezium. Okay, this one is trapezium, this one is trapezium, and trapezium. Or if you don't want trapezium, you can find the area of this triangle. It's comot already, so I want to erase first. Cannot. Eraser. It's comot already, so I erase first. La 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 la. I hope you're not stressed. Okay. Okay. Pen. Okay. Continue. Okay. If you don't want trapezium, you can use this as triangle. This as another triangle. This is triangle. And this is rectangle. Okay, so you must have 1, 2, 3, 4. Also can. Okay, so want to try? Okay, the first one, this is 2, here to here is 8, the height is 8, so 1 over 2 times 2 times 8 plus, okay, number 2 is this big rectangle, so from here to here is 16 minus 2, this is 14, and the height from here to here is 8, so 14 times 8, and then plus, okay, for this triangle, from here to here is 10 minus 4, so this is 6, and the height here is 2, from 8 to 10, right? So the height is 2, so 1 over 2 times 6 times 2, and then plus this triangle, the length here is 6, the height here is, okay, from 8 to 12 is 4, right? So 1 over 2 times 6 times 4, so you add all, okay, so this one is 8 plus 14 times 8 is 112, plus this is 6 times 2 is 12, 12 divided 2 is 6, plus 1 over 2 times 6 is 3, 3 times 4 is 12. So the answer is 112 plus 8 plus 6 plus 12. So the answer is 138. Okay, 138. Okay. But for this question, okay, sometimes it will not ask you the area for the whole journey. Okay, for this one it's simple, right? So maybe the question will ask you whole journey. Okay, this also same, find the whole journey because one straight line only. Okay, but for this it might ask you find the distance travel for after, let's say, 10 seconds. Okay, so that's mean okay, after 10 seconds you only calculate this, okay, until here only. This is the border, you don't have to calculate this one. What if the question asks you to calculate the distance for the last, okay, last 6 seconds, for example. Okay, so you only calculate this region, okay, this region only. Okay, it depends on the question. Okay, as long as you know how to calculate area of rectangle, area of triangle, area of trapezium, I think there is no problem for you. Okay, so please revise. Okay, next. Okay, examples for Examples. Okay, now we are going to calculate the distance. Okay, a car accelerates from 0 to 40. So from 0 to 40 in 8 seconds. Calculate the distance traveled. So what is the shape here? This is the shape of triangle. Okay, so this is 8, this is 40. So 1 over 2 times 8 times 40. Okay, and the answer is 160 meter. Okay, distance, find area. Okay, remember for speed time graph, find the distance is finding the area under the graph. Okay, next. The speed time graph below shows the movement of a particle for the first 50 seconds. Find the distance traveled. Okay, this one, it asks you to find the total distance. Okay, so easier if you use trapezium. 1 over 2 times 50. Here to here is 30 minus 10 is 20. So this is 20 and the height here is 30. So 1 over 2 times A plus B times height. Okay, so equals to 1050. Okay, okay, so the answer is correct. Okay, as I said just now, if you cannot remember how to calculate area of trapezium, okay, don't worry, you can still separate this diagram into 3 parts. 1, 2, 3. Okay, next. Okay, solving problem question. Okay, read the question. The following speed time graph shows the journey of a school bus for the first 50 seconds. Find the distance traveled for the first 30 seconds. Okay, so the keyword here is first 30 second, find distance. Distance, area under the graph. First 30 seconds, look at first 30 seconds. So this is 30 seconds. That means you must calculate the area of this trapezium. Okay, so you want to use area of trapezium? The one. Okay, it's okay. You can separate this into two region, trapezium and triangle. So for the triangle, 1 over 2 times base is 10, height is also 10. Plus, this is area of rectangle, 10 to 30 is 20. This to this is 10, so 20 times 10. So your answer would be 250. Okay, so question A, siap. Okay, question B. The acceleration during the last 20 seconds. So, last 20 seconds. Acceleration. Okay, last 20 seconds. But it asks you acceleration. Remember, acceleration is the gradient. Acceleration is the gradient. Last 20. 50 minus 20 is 30. So, from here to here. Okay, so you must find the gradient for this line. 30, 10. This is 20, sorry, 50, 25. So, acceleration equals to 25 minus 10 over 50 minus 30. So, equals to 15 over 20, so equals to 0.75 meter per second square. Okay, number 1 correct, number 2 also correct. Okay, C. This question will give you 6 marks. Okay, 6 or 5 marks, 6 marks. Okay, so this is easy, right? Okay, C. The total distance travel. Okay, total distance. You already know that for until here is until 30 seconds is 250. So plus with the last one here. Okay, 1 over 2 times, I use the area of trapezium. This is 20, this is 10, this is 25. So 25 plus 10 times with 20, so equals to 250 plus, okay, 10 times 35, so equals to 250 plus 350 equals 600 meter. So the total distance is 600 meter. Okay. Okay, let's check another question. The speed time graph shows the movement of particle for the first 9 seconds. Given that the distance travelled in the last 6 seconds is 39 meter. Okay, read the question carefully. Okay, the total is 9 seconds. Okay, given that the distance travelled last 6 seconds is 39. Last 6 seconds. 9 minus 7 is 2. Bukan kat sini 9 minus 3 is 6. Okay, so total here is 6. So from here to here, the distance 1 plus 2. Because why? Distance equal to area under the graph. So this area plus this area equal to 39. Okay, state the duration, okay, whereby the particle move at a uniform speed. Okay, uniform speed is this one, the horizontal line, remember? Okay, duration, how long? From 3 seconds to 7 seconds, how long? 7 minus 3 equal to 4 seconds. So answer A. Settle. B, 1. Find the value of A. Okay, value of A is here and here. You are given this information just now, remember? Use this info to find the value of A. So, look at this diagram just now. Here is A, the height is A, the length here is 4. So, the area is 4A, right? Plus with, okay, this is trapezium. Okay, this trapezium. Don't want trapezium, it's okay. Cut it into 2. So you have 3 parts lah. Okay, for this part, this is 2. This is A. So the area is 2 times A. 2A. Plus area of triangle here. This is 2. The height is A to 15 minus A. So A to 15 minus A pula. A plus 15. A plus 15 minus A. So this to this is 15. Okay, A minus A is 0, equal to 15. So the height for this triangle is 15. 1 over 2 times 2 times 15. This is the area from here to here. And the area is given 39. So you make it equal to 39. So from this equation, you can find the value of A. 4 plus 2 is 6. A plus, okay, this one, 1 over 2 times 2 is 1. 1 times 15 is 15 equals to 39. So 6A equals to 39 minus 15. 6A equal to 24. So A equals to 24 over 6. Okay, equals to 4. A equals to 4. Siap. Okay, so you know that this is 4. This is 4 plus 15 equals to 19. Okay, next question. The deceleration for the first 3 seconds. The question asks you to find the deceleration. Okay, deceleration, you must find the gradient. So, for the first 3 seconds. First 3 seconds here. Okay, so this and this. 0, 25. This is 3, 4. Okay, remember we found that A equal to 4. If you get A wrong, then your answer B2 is also wrong. So be careful. Okay, so C, 25 minus 4 over 0 minus 3. So equals to 21 over negative 3 equals to negative 7. The question, okay, this is the acceleration. Okay, the acceleration. So the question asks you to find deceleration. So the final answer, deceleration equals to 7 without the negative, because okay, deceleration. Okay, so settle for this question. Next. Okay, the diagram shows the speed time graph of a bus given that the total distance traveled is 2.24 kilometer. Okay, so this one, 2.24 kilometer is the information given. Okay, find the value of V. Find the value of V. This is total distance. Total distance. That's mean 1 plus 2 plus 3. Okay. If you want to use area of trapezium also can, no problem. Okay, but I separate into 3. Okay. So 1 over 2 times 30 times V. Okay. Plus, okay, this area for A, this is 30, the height is V. This one, 60 minus 30 is 30, the height is V. So the area of this rectangle is 30 times V. Plus, this is also a triangle. 110 minus 60 is 50. The height is also V. So 1 over 2 times 50 times V. This is to calculate the total distance, right? And the total distance is given in the question. 2.24 kilometer. But be careful here. Speed in meter per second. The length of the distance given is in kilometer. So you must convert it to meter. Kilometer to meter, you must times 1,000. So this is 2,240 meter. Okay, so we be careful with the unit given. Okay, now we simplify the left hand side. Okay, 30 divided 2 is 15. So this is 15 V plus 30 V plus 50 divided 2 is 25. So 25 V equal to 2,240 meter. You add all of this value, 15 plus 30, 45. 45 plus 25 is 70. Yes, 70. 70 V equals to 2,240 meter. So you don't have to write meter in solution, it's okay. V equals 2240 divided by 7. So V is equals to 32. So the value of this is 32. This is for question A. Question B. The distance travelled in the first 30 seconds. So first 30 seconds, it want the distance. Distance is finding the area. So for the first 30 seconds, the formula, the area of triangle, you are actually have this one just now. Okay, remember? Okay, so the area for the first 30 seconds equals to 15V, so equals to 15 times 32, so equals to 480 meter. Okay. Okay, summary. So in this video, first, we discuss about the shape, the shape of the graph, for speed time graph. For the speed time graph, when the line is like this is uniform speed. When the line is like this, increasing speed, like this, decreasing speed. Okay, 2, we discuss about the gradient for speed time graph. Okay, so the gradient for speed time graph represent the acceleration. Okay, so that means you must find the value of gradient to find the acceleration. And acceleration have two values. One is positive value, another one is negative value. For positive value, when the graph is like this, that means the speed increase. Negative value is when the graph like this, the speed decrease. If the question asks you to find deceleration, you don't have to write the negative sign. For this one. Number 3, we discuss about the area under the graph. Area under the graph for speed time graph is equals to the distance. Area under the graph for speed time graph is equal to the distance traveled. So if you are going to find the distance, you must find the area under the graph. But be careful, look for the keywords from the question, because the question will not just ask you to find the total distance. Maybe it will ask you the distance for sometimes, for the first 10 seconds or for the last 15 seconds. So you must be careful, read the question carefully. So I think that's all for this video. I hope this video can help you to understand the topic and how to answer the question involving the speed time graph. So have a nice day. Bye bye.